While working with structs and enums, you may have already come across using proc macros or procedural macros as they are known, but don't really know why we use them and what is it actually doing to our code. A proc macro is simply a program that takes in a Rust code as input such as a struct or enum and gives additional Rust code as output during compile time. One of the most common proc macros you might have already seen is debug, that is added over structs and enums when we want to print that struct value in our terminal. Visually, at high level, this is what happens when you add the derive debug to a Rust struct. Some new code is generated while the code compiles. But why do we need a proc macro over a struct? And what does the newly generated code actually do? The new generated code basically adds additional functionalities and trait implementations over a Rust struct. That's the job of a proc macro in Rust. And as these generated code can be repetitive a lot, you can make new structs and avoid writing it over it again and again. So it's much more easier to just use a proc macro on them rather than to write the implementation for each struct. So it generates the repetitive code for you. Take an example of the simple struct with debug proc macro attached to it. The macro expands the code to create new Rust code during compile time. It creates a format implementation for the user struct, which can be used while printing value using the println statement. But how are these macros generating new code to add? At a high level, your previous struct is first transformed into a stream of tokens, also known as TokenStream, of each code word. Out of these tokens, depending upon the macro logic, it takes the field names, in this case name and age, to generate new code which implements a trait over the struct. Here the debug macro implements format function over the user struct so it can be printed over our terminals. Then the struct newly generated code are included together in the final program binary after the compilation is done. Here is an example of workings of the debug trait. Without the macro, the program will fail to print the struct on the terminal. When we add the macro, the code is internally expanded to automatically implement the debug trait on the struct, and now we are able to print it.